Let there be light. The Big Bang. Our universe begins with a moment of unimaginable intensity, a colossal explosion that marks the birth of everything we know. Picture a point smaller than an atom, containing all the energy that will ever exist. This tiny, almost inconceivable point is the seed of the universe. This is the singularity, the starting point of everything we know. It is a moment of infinite density and temperature, where the laws of physics as we understand them break down. In a fraction of a second, this singularity expands outward in a massive burst of energy, a process known as cosmic inflation. This is the Big Bang, the event that sets the stage for the creation of the universe. The newborn universe is a chaotic sea of energy, a turbulent and dynamic environment where the fundamental forces of nature are just beginning to take shape. Space and time, as we understand them, are still forming. Temperatures are unimaginably high, reaching billions of degrees. As the universe expands and cools, energy begins to condense into particles. These particles are the first building blocks of matter. These are the building blocks of everything in the cosmos, the first whispers of atoms yet to come. Protons, neutrons, and electrons begin to form, setting the stage for the creation of atoms. Imagine a universe filled with light, an endless ocean of photons racing through the expanding void. This light is the first radiation, a brilliant afterglow of the Big Bang. This is the early universe, a time before stars and galaxies, a time when the universe was bathed in the afterglow of its own creation. It is a period known as the cosmic dawn. This light, stretched and faded over billions of years, is still detectable today as the cosmic microwave background radiation. It is a relic of the early universe, a snapshot of the cosmos when it was just 380,000 years old. It is a faint echo of the Big Bang, a whisper from the dawn of time. This ancient light provides us with a window into the universe's infancy, allowing us to glimpse the very beginning of everything. The forge of the cosmos. The chemical stage. As the universe expands and cools, the primordial soup of particles begins to change. Protons and neutrons, the building blocks of atoms, start to form from the cooling energy. These particles collide and interact, eventually fusing together in a process called nucleosynthesis. This is the birth of the first elements. Hydrogen, the simplest and lightest element, is the first to appear. Vast clouds of hydrogen fill the early universe. Helium, with 2 protons and 2 neutrons, soon follows. These 2 elements, forged in the fires of the Big Bang, will become the most abundant elements in the universe. The universe is still young, but it is already teeming with the potential for complexity. The stage is set for the formation of stars, galaxies, and all the wondrous structures we observe in the cosmos. Within the hearts of these celestial objects, heavier elements will be forged, adding to the rich tapestry of the universe. From chaos to order. The celestial stage. The universe, a vast and mysterious expanse, is a grand theater where the drama of creation unfolds. Gravity, the architect of the cosmos, begins to sculpt the early universe. This invisible force pulls matter together, shaping the very fabric of space and time. The vast clouds of hydrogen and helium, remnants of the Big Bang, are drawn together by their own gravitational pull. These primordial elements are the building blocks of everything we see today. These clouds collapse inward, becoming denser and hotter over millions of years. The process is slow and relentless, driven by the inexorable pull of gravity. Eventually, the pressure and temperature at the core of these collapsing clouds become so intense that nuclear fusion ignites. Stars are born, lighting up the cosmos with their brilliance. These early stars are massive and short-lived, burning brightly for millions of years before exploding as supernovae. Their lives, though brief, are spectacular and transformative. These cosmic explosions scatter the newly forged elements into the surrounding space, enriching the universe with the ingredients for planets, life, and ultimately, us. The debris from these explosions seeds the cosmos with the raw materials for future generations of stars and planets. As stars ignite and fade, They gather together under the influence of gravity, forming vast collections of billions of stars galaxies. These galaxies become the fundamental building blocks of the universe's large-scale structure. Our own Milky Way galaxy, a barred spiral galaxy, is just one of billions upon billions of galaxies in the observable universe. Each galaxy is a cosmic city, teeming with stars, planets, and the potential for life. Within one of its spiral arms, a nondescript cloud of gas and dust begins to collapse, eventually giving birth to our own solar system and the planet we call home. This process of star and planet formation continues to this day, a testament to the dynamic and ever-evolving nature of the universe. Section 4. A spark of life, the biological stage. Billions of years after the Big Bang, a remarkable transformation occurs on a small rocky planet orbiting an average star. On our Earth, in the primordial soup of the early oceans, life emerges. The exact details of this momentous event remain a mystery, but we know that simple organic molecules, the building blocks of life, somehow assembled and began to replicate. These first life forms are single-celled organisms, primitive bacteria, and archaea. They are simple, but they possess the extraordinary ability to harness energy from their environment and make copies of themselves. Life, once sparked, begins its slow and relentless journey of evolution. Over billions of years, life on Earth diversifies and evolves. Photosynthesis develops, allowing organisms to harness the energy of the sun. Oxygen, a byproduct of photosynthesis, begins to accumulate in the atmosphere, paving the way for more complex life forms to evolve. The stage is set for the next great leap forward in the story of life, the emergence of multicellular organisms. Section 5. Strength in unity, the cooperative stage. From the simplicity of single-celled organisms, a new level of complexity arises. Through processes that are still not fully understood, cells began to cooperate and form multicellular organisms. This transition from single cells to multicellular life is a pivotal moment in the history of life on Earth. These early multicellular organisms are simple, but they represent a profound change. Cells are no longer independent entities, but are now part of a larger, coordinated whole. This cooperation allows for specialization, with different cells taking on different tasks within the organism. The evolution of multicellular life leads to an explosion of diversity. Plants evolve, harnessing sunlight to produce energy. Animals evolve, developing complex nervous systems and the ability to move and interact with their environment in increasingly sophisticated ways. The tapestry of life on Earth becomes richer and more intricate with each passing millennium. Section 6. The dawn of consciousness, the cultural stage. Millions of years after the first multicellular organisms, a new kind of life emerges on Earth, conscious life. This marks a pivotal moment in the history of our planet, a moment that would eventually lead to the rise of human civilization. Human beings, with their large brains and capacity for language and abstract thought, represent a significant departure from the rest of the natural world. Our ability to communicate complex ideas and emotions sets us apart from other species. We are the universe becoming aware of itself, capable of contemplating our own existence and the vastness of the cosmos. This self-awareness drives us to explore, to question, and to seek meaning in the world around us. With the advent of consciousness comes culture. Culture is the collective expression of human creativity and intellect, manifesting in countless forms across different societies and epochs. Humans develop language, art, music, and complex social structures. These cultural elements become the building blocks of civilization, enabling us to share knowledge, preserve history, and build communities. We begin to ask questions about our place in the universe, seeking to understand the world around us and the forces that govern it. Philosophers and thinkers ponder the mysteries of existence, laying the groundwork for future scientific inquiry. This quest for knowledge leads to the development of science, a powerful tool for unraveling the mysteries of the cosmos. Through observation, experimentation, and reasoning, we begin to unlock the secrets of nature. The human story is still being written. Each generation builds upon the achievements of the past, pushing the boundaries of what is possible and striving to create a better world. We are a young species, capable of both great acts of creation and terrible acts of destruction. Our technological advancements have the power to transform our lives, but they also pose significant risks. The choices we make in the coming decades and centuries will determine the fate of our species and the planet we call home. Environmental stewardship and sustainable practices are crucial for ensuring a livable future. Will we use our intelligence and creativity to build a better future for ourselves and all life on Earth? The potential for positive change is immense if we work together towards common goals. Or will we succumb to our baser instincts and destroy the very things that make life worth living? The path we choose will shape the legacy we leave for future generations.